Hey, welcome back. This is the final, I think, episode of the Programming Robots video series that I chose to put together tonight. I've been meaning to do this video series for a long time, so it feels good to finally just get all these ideas and words out, and it went relatively well for what I wanted to convey out for other people learning. Because it's not a hard thing to program these robots, but without starting from scratch, basically, it's a little bit daunting of a task to get through just this amount of things that we've already done here if you followed all the episodes in just a couple hours. So I guess let me run this just for fun, just in case you didn't check out the other videos or it's been a while. But our robot goes with this tool and pushes his e-stop on multiple controllers with multiple work objects and things like that. So these could be cars coming down the line and you're stopping and welding on them, or any of that kind of stuff. It's all pretty much the same once you get what you need to do, and then of course that leaves you with we just drug a big pyramid pointer made up thing across these parts, but hopefully you can see that's going to be a spindle or a welder or something, and that kind of takes me to the last bit of walking you through how you would actually integrate the system. You have a few choices, of course. You can do like a PLC or something like that alongside the robot controller, and they would talk to each other over various field buses or digital I/O or something like that. It really depends on the complexity of the cell that you're working on, or if you're just playing around, or if you're making something that's actually going to end up in a factory. Maybe you're doing machine tending and you're talking directly to a CNC machine with hard I/O, or you can do whatever you want. Basically, you have these open kind of communication channels that you can talk to in the robot, and over in this rapid programming land, you have the ability to talk to a lot of that stuff. So, like I said many videos ago, when I get right in on that e-stop button, if I wanted to do something, pop a rivet in the hole, for instance, or that I drilled, or drill a hole. Say I want to come up and I want to tell the robot's drill to actuate. Um, you could do let's see, it's a set DO, and you have a couple options here of how to sync it if you want to, or what the signal is. So you would write like drill now, or start drill. Um, and basically it's whatever you called that. It's called a signal, and at least in ABB it's called a signal. Um, and you would set it to 1, and then maybe you do a wait DI, drill complete, equals a 1, and you give it a max time equals 5 seconds, and maybe that throws an error down to the system, which will show up on the pendant, or you can send out the errors and all that stuff. So essentially, you need to think about how your robot's going to actually perform work and bring that into the motion of it. So get the robot to position, do a motion, or get the robot staged for a linear movement and actuate the spindle and turn it on. Maybe it's like I've done one with set AO, set analog output, spindle speed, and then 30,000 units. So that would be like an analog signal to a spindle or something like that. Oh, sorry, it would be set AO, not wait AO. But either way, so these wait will just sit here, and the robot will do nothing basically until it carries on. And you can have multiple tasks if you have to have things going on in the background, but if the drill operation is really complicated, you'll probably have a PLC that says PLC start drill, or actually, sorry, this is the PLC done drilling. Something that is got to do a lot of things, or a welder's going to handle a process. That'll all happen here, and so you set that stuff up in the configuration of your controller. So you can come in here, I/O system signals, and you can see all these default signals that this is when you actually get into integrate. You would have a lot of the PLC signals tied into a lot of these things. So enable, well, some of these are internal, but you should have some, soft or e-stop. You have ways to start the programs, things like that. And so you can say, hey, on this digital input or this, select programs with 3 different inputs, all sorts of different stuff you can do. But I just wanted to make sure I didn't get through the end of this video series without saying anything about like what comes next and how you would implement something like that. So that's sort of what I did in my PLC video, and it's still helpful, but essentially you can put in all these networks, you can add new industrial networks to talk to the outside world, and that's the gist of the work. Once you understand the basics of teaching points, the real work is in recovery. What happens if you e-stop and your robot's tucked up in a tight space? Well, how do you handle that? And there's a bunch of ways to do it, but I've yet to find something that makes it super easy to take care of that. So you really have to put a lot of thought in it per application, and make sure that you think that through. Or some people will force you to jog out of there with the pendant, but even it can be kind of a dangerous, not to people if it's done right, but a dangerous to hardware situation when you get these robots flinging stuff around. But if you're the programmer, it's your job to try to minimize all of those problems and keep production going, obviously. So um, that's about it. I just wanted to explain that there is some stuff in here, to get the program to start automatically from an external unit. You're not going to just sit here and hit go every time or whatever. So you'll have some sort, if something comes in on a conveyor, it's going to sense the part, start a program, do all that good stuff. So um, you set all that kind of stuff up in here, and then while you're running, you can open up this I/O system, and you can make changes to the I/O, read the I/O, see what it's doing, and that's where you're actually other than the motion and positioning, you're interacting with the tool and the parts on the conveyor and all that good stuff. So I think that's about it. So props if you stuck around the entire time. And give me some feedback if you want me to do some more videos like this. As I'm learning new things, once I get to a point where I think I can do some videos, I'll try. But otherwise, just like and subscribe if you enjoyed the series. Thanks a lot. Catch you next time.